And for today's meteorology segment, we've decided to stream live to Twitch. Twitch.tv/smAsho is where this video first appeared. Check out their mobile app, by the way. It'll alert you when we're streaming live. And part of the source of the incoming precipitation just starting to make landfall here in places like Louisiana and Mississippi is because we've got 85.5-degree water here. And that has a tendency to strengthen tropical systems. So one of the ways that we forecast correctly whether a hurricane will strengthen or weaken is by looking at the water environment. You can see how hot the water is here, southeast of New Orleans. 85.5 degrees for the ocean surface temperature in that area. And we're going to talk about more kinds of temperature type of stuff here on today's meteorology segment. So put on your seatbelt. It could be a wild ride. So let's just take a look at the normal stuff that we usually look at here. We're going to look at the surface winds. So here are the surface winds of this same area, and you can see this powerful onshore wind here. It's not hurricane force, but it is going to be dropping quite a lot of rain, and we'll show you the rain forecast momentarily. Let's zoom out and look at the global surface wind environment. There's the surface wind environment of the Western world. Here's the 250 hectopascal winds, otherwise known as the jet stream, and look at how absolutely chaotic the jet streams are over this portion of planet Earth. Totally incoherent jet stream there. It's all over the place, blowing backwards here over the Central Pacific Ocean. And look at the extreme bends here over the North Atlantic. 180-degree bends here over only a couple hundred miles. Here are the jet streams of the eastern world. Come on, planet, rotate. There we go. There are the jet streams of the east. A little more coherent on this side of planet Earth. I would also note that they are blowing backwards over the western Pacific and over the Indian Ocean. Backwards jet streams, once again, folks. We've documented it repeatedly. If you haven't watched our previous meteorology segments, maybe check them out. Anyway, there are the surface winds of the eastern world. Moving on to thank our patrons, the true source of funding for the content. Thanks, patrons. Consider becoming a patron if you want all kinds of information before anybody else gets to see it. We send out all sorts of alerts about everything from coronal mass ejections to electron storms to proton flux, radio blackouts. Patreon.com/smAsho. We also provide multimedia, things like ringtones and graphics nobody else gets to see, unless shared by one of our patrons. Thanks again to our patrons. So we've got a SciTech Daily story here, and we regularly cover phys.org articles about global warming. Here's a great alarmist story for you here. Global warming already responsible for 1 in 3 heat-related deaths, allegedly. And you never see articles about cold-related deaths where people freeze into a solid block of ice. But heat-related deaths are all over the news lately because yellow dog journalists keep picking up ridiculously nonsensical stories. And I'm just going to let this one scroll here. Overall, the estimates show that 37% of all heat-related deaths in the recent summer periods were attributable to the warming of the planet due to the false premise of anthropogenic activities. Yeah, so it's your fault, folks. Your carbon emissions are allegedly killing people. Estimates show the number of deaths from human-induced climate change that occurred in specific cities. 136 additional deaths in Santiago, Chile, that are your fault. 172 in Rome that are your fault. 189 in Athens that are your fault. 156 in Tokyo that are your fault. You've killed 177 people in Madrid. 146 in Bangkok, 82 in London. Why did you kill 141 people in New York City? Why did you kill 137 people in Ho Chi Minh City? Why is that, folks? Why do you keep driving your SUV? Why do you keep charging your Tesla with coal-fired power plants? Why must you keep killing people with your carbon emissions? Pardon my sarcasm. Carbon dioxide does not control the planet's climate. It's a ridiculous idea to suggest that it is, and it represents ignorance and arrogance of both the geologic record, thermodynamics, and the understanding of physics in general. researchers have found that the Earth energy imbalance approximately doubled during the last 14-year period from 2005 to 2019. Which is why they're showing you this cherry-picked and very, very scary and spooky animation here. Look at how scary this is. Oh my God. The total radiation and the planetary heat uptick. They're both ticking up here, and they've conveniently brought you back to show you this low point at the last solar minimum. That's the solar minimum between cycle 23 and cycle 24, folks, where the thermosphere got much colder than it is now. So I'm going to let this article scroll here. Like every bit of nonsense you'll see on the internet, this has got little grains of truth, which help to thread together the rest of the nonsense that they're expecting to get you to believe. The two very independent ways of looking at changes in Earth's energy imbalance are in really, really good agreement, and they're both showing this very large trend, which gives us a lot of confidence that we're seeing the real phenomenon, not just an instrumental effect, says Norman Loeb, lead author for the study and principal investigator for Ceres and NASA Langley Research Center in Hampton, Virginia. The trends we found were quite alarming in a sense that they're showing you only part of the data. Now, if they showed you back until 1959, this instead of this line looking like this line would look like this, because going back to 1959, when the thermosphere was the hottest it's ever been, it would look completely differently. So if you look at the thermosphere data, in other words, if you know anything about this and you look at the thermosphere data, look at how hot the thermosphere was at the most active sun that we've ever seen. That solar maximum right there featured a hot thermosphere, the only time it was ever measured to be hot. I would also note that this solar minimum featured higher cosmic ray flux and the coldest thermosphere ever measured. It's not that cold anymore, and this data is a little bit old. This article is actually from 2018 here. And you can read about this on spaceweather.com. And let me show you the most recent data about the thermosphere. Here's the most recent data. If you head to spaceweather.com and you scroll down here, now this hasn't been updated, unfortunately, since the end of last year, but it will make my point regardless. See this? That's the coldest the thermosphere's ever been measured, and what that graph has shown you is from here to here. That's all that graph was showing you, that scary, spooky graph that we just showed. Let me bring that back up. See this scary, spooky graph? That's from 2005 until not even current. So it's, yeah. So 2005 is right about here. It's only showing you from here to about here. So if that's an alarming trend, here's the actual thermosphere trend from 1959. See, what I've done is I've cherry-picked the data. So there's your trend, and a perfect example of cherry-picked nonsense when it comes to climate. Let's go back to weather stuff, and just give me a minute to check the life of the stream here. Again, we did stream this live. And we actually heard some thunder, which woke us up this morning. You can see some lightning here across Pennsylvania and the Midwest, Iowa, Illinois, Indiana, and Ohio, experiencing some significant lightning, as well as some lightning here on the Gulf Coast associated with that incoming tropical system. It's probably not going to get named a tropical storm because the wind speed is far too low. Here's a real-time lightning map as we're wondering if there's any thunder rolling in now. And indeed, there's quite a bit here in places like Indiana. So Indianapolis, you're surrounded. Go out and, if you're on a skyscraper, go out and check out what's going on around you. You may get some spectacular imagery here. Hey, Martinsville, there's thunder rolling in. Next time you hear thunder, check out lightningmaps.org, powered by blitzachtung.org. Check it out. We've got an errant lightning bolt here in Canada near Edmonton, Alberta. Actually, pretty far from it. Ochiese First Nation. So, seeing some lightning there on apparently an Indian reservation. Cheers. And I'd also like to welcome everybody to the Neo Renaissance. Check out our own website, smashamash.com. Smashamash.org will redirect you. If you click on smAsho merch, you'll be directed to our Redbubble page, which has got everything discounted throughout the month of June. So once again, we're featuring the Vaccinate This t-shirt in orange, which I'm currently wearing, since my vaccination status is absolutely none of your business. Are you my doctor or my insurance company, or perhaps a physician's assistant or a nurse at my doctor's office? What's that? No? Then you have no legal right to any of my medical information. Again, if you head to smashomash.com, click on smAsho merch. Everything is discounted throughout the month of June, so pick up your gear early before summer arrives. Get it on the way. And again, this is the My Vaccination Status is None of Your Business design. If you're wondering if I've been vaccinated, the answer is I'm not telling you. Continuing on to look at pressure as the meteorology segment continues. We've got low pressure over the entire U.S. Check it out, the whole U.S. encased in low pressure and surrounded by high pressure. Anyway, we'll advance this. There's where things are expected to be via the European forecast tomorrow at 1 o'clock. That's 1 p.m. Eastern Daylight Time. By the way, there's an extreme drought going on, an exceptional drought in places like Utah, Nevada, Arizona, New Mexico, California, and even some in Oregon. And by the way, that is an earthquake risk. There is a proportional relationship between droughts and earthquakes. Perhaps check out this article here. Lake Mead, America's largest reservoir, is drying up as a result of this 22-year-long drought. So the possibility that this could lead to large earthquakes, it's probably because of things like underwater aquifers being filled with water or being empty and collapsing and so on. It's a pretty basic concept here, but there is certainly a recently shown relationship between droughts and earthquakes. We're hoping to not see a major earthquake in some place like the Cascadia region, as it is long overdue. And again, planet Earth is largely overdue for large earthquakes, period. We've been seeing a drought of 6.5 magnitude and larger quakes for the past about 30 days. And I'm just letting the article scroll here in case you want to read it. It's a pretty unfortunate drought going on. We're hoping to see some rain in these regions. Anyway, that article, courtesy AccuWeather.com. So here's the forecast. This is through Thursday, June 24th. We're seeing some heavy rain expected in Florida. I just included that because they're forecasting like 6 inches of rain there for parts of Florida. So that's the Tropical Tidbits GFS forecast for total accumulated precipitation. And fortunately, the Gulf Coast has been downgraded. They're no longer forecasting like a foot of rain there. Now it's only more like 4 inches, 4, 5, 6 inches. Some good news there, as the system looks like it's weakened. Let's take a look at it. And here's the U.S. Doppler radar map. And you can see those heavy bands of rain making their way into mostly Mississippi and Alabama, also now Georgia and the Florida Panhandle. Strong storms also over Illinois and Indiana and Ohio and Wisconsin. And they're about to move into Michigan, moving across the lake right now, creating some stormy conditions over the water. And let me just refresh that again. We are streaming live, so we've got to bring up the NASA GOES interactive weather satellite cloud map. There's what's going on in the cloud layer. And here comes the water vapor map. Just give me 1 minute. There we go. And that should give you some insight into how things will progress. This dry mass of air right here is actually helping out to keep all that moisture out of Louisiana, as you can see. It's providing a barrier with its dry massiveness. Anyway, here's a recap. There's a U.S. Doppler radar map. The trailing edge of those storms here moving into Illinois feature some quite large red bands there. That's going to be producing things like high winds and possibly hailstorms, possibly even tornadoes, so keep your eye out for that. Here's the cloud layer. And there's the water vapor map, which should give you the most possible insight into the way these systems are going to move. Thanks for tuning in to today's meteorology segment. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted. Name and news.